Okay, I'll get started. My name is Victor Phoenix. I'm a sound designer, technical sound designer for mostly VR these days. I started with games, worked at Pandemic Studios, Sammy Studios, and Turtle Rock Studios, Robotoki. So I moved out of AAA game development in 2014. Full-time, and moved into VR. So that's generally where I've spent my time. Still focusing on interactive sound, so I'll be talking about spatialization, because it's a big part of VR audio, and how I've used Wwise to make that both easier and faster to implement and just generally sound better. So I'll be talking a little bit about a project I worked on at the end of last year, the beginning of this year, called Passengers Awakening. It was a product related to the VR, or to the movie, the VR experience related to the movie. And I'll talk about a few different aspects of my work on the project, what worked, what didn't work. I was for that particular project, I was the dialogue supervisor, as well as the technical sound designer. A technical sound designer, we had a few. My focus was on the narrative elements, recording, creative processing the VO, spatializing all those narrative elements, blueprint scripting, and as well as integrating Wwise and the spatial plugins. So I wanted to break up the talk a little bit into two sections. One's about a little theory about why spatialization is important. And how important it is to large aspects of VR in general, but also any immersive content. And then I'll talk a little bit about the nuts and bolts of how I walk you through how I implemented and made some setting choices and worked on some mix aspects, and give you some considerations for spatializing your own sound. So I wanted to start by describing and defining agency, which will relate to the real-time spatialization aspect eventually in this talk, so bear with me. So agency really is the ability of a person to take action in life. And in a game or an immersive experience, that action can and generally should have some effect on the environment, on the world. So that degree depends on the goals of the designers of the project. But the basic idea is that we get a sense that our actions affect the environment or the narrative, or both, in a meaningful way. So agency can affect changes in a few different ways. So they can happen in the time domain with sound, just to give you a brief overview of how those changes can happen. And domain effects are like delays, variations in amplitude over time. A waveform display is a great example of seeing those variations over time. The speed of sound delay. So just thinking about how a user's actions can affect sound over time, and how the waveform here over time shows you the different amplitude changes. Same thing about frequency. With frequency, sound can be changed over time by adding filters, removing frequencies, adding frequencies, summing frequencies, and sounds are affected by the environment at different levels. For their frequency information is affected in different ways. So as things happen in an environment and the player does things, those sounds, the frequency information in those sounds can change. So just to compare how frequency can intersect perpendicularly with time, and in VR especially, but any immersive content, we want to start thinking about sounds in the spatial domain and how those changes can happen. Events now, we need to consider their height and how they relate to the player, and objects moving through 3D space. And for sound, those sounds also are going to be moving through 3D space. Our bodies in the real world affect how we hear those sounds. And they all, what they really lead up to is a changes in perspective for those sounds. And that's important to both game and story. So we want to consider how these changes both affect the sounds and how they affect the players, and how the players view the experiences that they're in. And one of the reasons this is so important and the reason I talk about VR, or agency, is because in VR, we've removed the disembodied camera and replaced it with this concept of agency. You may be wondering why I'm focusing so much on agency when this presentation is on spatialization. It's pretty simple. Because agency allows users to change their own perspective. That means they can change the sound relationships at their will. The goal of this is to kind of create a suspension of disbelief in VR. So you're in a virtual environment, you feel compelled to do something, you're able to make that change, and your brain can say, I made a change in that place. You get a sense of being present in that place. And when we're able to suspend our disbelief, we get a real sense of being in that environment. That's called presence. So all of this work for spatialization is to not only support agency, but ultimately to support presence. So it's very critical to the success of VR, especially because presence is a subjective experience. It's intuitive, it's sensorial, it's a little bit hard to describe. It's really a feeling more than anything. And it's actually the very definition of virtual reality. So we need to consider the presence when we're talking about virtual reality, and we need to consider how spatializing sound supports both agency and presence. So we're really looking towards creating successful virtual experiences with spatial audio, so that when the players have this agency and they have this awareness, they're able to execute this agency and develop this awareness through their actions. And if not, that presence is diminished. So let's talk a little bit about the importance of spatial audio for presence. It's critical. And it's been scientifically shown to induce a higher level of immersion or presence on a subconscious level compared to non-spatialized audio. It supports localizing sounds in 3D space, which is when you're immersed in a virtual environment. You have access to sounds and objects above and below you that you wouldn't necessarily have in a 2D experience. And sound gives you this unlimited field of view. So we need to use that in a way that supports the game. So when I talk about spatial audio, I'm really referring to two different forms. A pre-rendered audio that has like binaural recordings, or anything with any HRTF spatial information already printed in the audio, and real-time audio, where audio is filtered and processed at runtime. And I want to focus on real-time audio because as game developers, being able to procedurally generate content and experiences is important to the goal of most games, right? We want to be able to have 50, 60 hours of content without having 50, 60 hours of pre-rendered content. That's the point of a game. So we need to use these concepts to better use the limitations that we have with the platform, both with CPU and memory, but to support, going back to supporting agency and presence. Because when you pre-render audio, you're locking the user into a single perspective. And when you're running it audio in real time, you have multiple perspectives, and you're letting the user drive those perspectives. So, like in anything with games, there's trade-offs. So, don't have enough CPU cycles. There may be ways to fake aspects of spatialization. You don't need to render everything at runtime. Maybe, and I'll talk about this with passengers. I pre-rendered late reverberations and used a attenuation curve to differentiate the pre-rendered late attenuations from the runtime spatialized mono source. So I was able to balance some of those limitations out. And spatializing in real time generally requires less memory usage too, because when you're printing and rendering everything, that all has to be loaded into memory as well. So again, I really just want to hammer this point home, that how important real-time spatialization is to agency. And it needs to match the degree of agency in every experience. So 360 videos, they don't necessarily need full object-oriented spatialization. A sound field could work best. You're not moving through a video experience. But when you're working on interactive VR and you have a full 6 degrees of freedom, you're able to roll your head and rotate and turn, and as well as move forward and backwards and up and down. The spatialized audio ideally should match that level of agency. When it doesn't, that presence gets diminished. So, talk about passengers a little bit. So, in passengers, the dialogue itself, I broke into two aspects. Like I mentioned, I had mono point source dialogue lines, and those were positioned on different places for the different characters, and each character had a little bit of a different role, so that helped differentiate them. For example, there was a handheld tool that's in this screen grab here, and dialogue came from that tool, and it was important to spatialize the mono point source for that line, because that controller was tied to the position of the controller. And generally, when users were starting out this experience, the controllers were down here below field of view, and we needed to give them height information. We needed to let them know there is an object below your field of view. And with 3D positioned audio, so I want to differentiate a little bit between positioning in 3D space and spatializing. They're tied together in the sense that, especially in Wwise, when you enable through 3D positioning, the object is still in 3D space. But if it's not spatialized, it uses panning techniques that are tied to your speaker configuration. And when you're spatializing, you're able to add in more information to give that 3D metadata more accurate positioning in 3D space. You're able to get elevation, you're able to get front and back information, and that's all rendered out at runtime by the plugins. So by pre-rendering the dialogue reverb layers, the late reverb, there were some pros and cons. I think I was able to retain some creative control, and that's something that is appealing. I had a conversation with somebody recently who felt that spatialization actually was less important than environmental quality, the environmental sound and the way sounds work in the environment. I think they're both important, but it's almost like an easy sell when something has a aesthetic fidelity to it and it sounds really impressive. That can kind of sometimes overcome, especially a user who isn't so used to spatialization, like localizing a sound in 3D space. In the same way that a low fidelity experience, a low aesthetic fidelity experience that has a really high degree of interactivity can overcome the lower production values and whatnot. So the bad news is it locked perspective, and with this experience, generally you were teleporting through, and we're still working on, every experience tends to have different locomotion systems, but when there were definite moments when you're in a variety of sized spaces, and you could be at different proximities to walls, and not being able to update the those early reflections for those walls at runtime gave this diffused sense to the sound, rather than adding to the information that I had spatializing the mono sound. For example, I had a sound tied to the controller, so if I'm moving my controller here, I get a very clear sense of where it is around me, but the late reflections don't really give me a sense of the environment. And if that sound was here tied to this wall, and I'm not getting that information at runtime in that ear, it gives it a more vague, diffused sense. So that wasn't great. It also complicated the localization. One of the reasons we chose Wwise was for its strength with localization, but needing to print the reverb layers for all the languages complicated both the mix and the production, because different actors will hit reverb in a different way, and it turned what should have been a couple days of work into a couple weeks of work. It also increased the memory footprint. For this particular project, I didn't have a lot of CPU resources available to me, so it was a trade-off that we felt was appropriate. So I'm going to play a video real quick of the final product. And give you an example of how the pre-rendered reverb sounds in the space. And we'll start with a scene where the player's character is inside of a pod. The pod opens up, and you'll hear the pre-baked reverb switch from this closed reverb sound to a more open sound. And then I'll move forward a little bit so we can hear different aspects of the reverb, and I'll show you how I did in Wwise.
On the starship Avalon, in transit from Earth to your new home, world of Homestead 2.
Let me go back a little
new
bit.
World, a fresh start, room to grow. Perfectly normal to feel confused. You've just spent 120 years in suspended animation. You're a passenger on the starship Avalon, in transit from Earth to your new home, world of Homestead 2. A new world, a fresh start, room to grow. The Avalon is on final approach. Enjoy the rest of your voyage.
So this next shot, you'll hear the tool that you're holding in your hand. That sound will become positioned from the controller. A little hard to get over speakers, but
teleportation. Forward on the move pad to pick a destination.
Passengers.
To jump. Perfect.
okay. So
Try jump.
we jump ahead to a couple different scenes where we move from a corridor to
Welcome to the observatory.
observatory.
Rotor's failing. I'm trying to fix it. Hang on.
We do apologize for that unexpected turbulence.
It's a little hard to discern the reflections from the video and from the room, but let me show you how I did that in Wwise. So these are my, first of all, there's a positional bus that the 3D plugins are attached to. And I can show you how I do that. I used Wwise's the function of linking, platform linking, to differentiate between two different plugins. This is the PS4 view, and for Windows, you'll see the Oculus Spatializer view. Oculus Spatializer plugin comes in. So I routed the sounds to different buses and updated my parenting appropriately. So this is a cruise director.
We are the Homestead Company, and your future is our business.
And the parent container I set to the basic positional bus. Worked a little bit a reverse where I went down, as I dug down, instead of routing stuff to the spatializer because I knew which ones I needed, I routed stuff away from the spatializer. So reverbs, for example, I would override the parent bus and send them to a specific non-spatialized reverb bus, and used different attenuation settings for the reverb. So this is an attenuation curve for for the spatialized sound, and this is the attenuation curve for the reverb layers. And I used some high-pass high-pass filtering to show and simulate how sounds kind of lose some energy over space and they get thinner, but also increased the balance between the wet and dry sound.
We are the Homestead Company, and your future is our business.
So it's pretty clear. I'll show you on this character, Arthur.
I can make 1,436 cocktails. I can make 1,436 cocktails.
Let's make sure we're hearing that.
I can make 1,436 cocktails. I can make 1,436 cocktails.
Yeah, we're losing some of the spatial information in the room. But,
I can make 1,436 cocktails.
But what I tried to do was give a balance between, like I said, pre-rendered, low CPU usage, high memory usage sounds, and real-time spatialized sound, and using the mix to affect the direct and indirect levels, and being able to use share sets to carry that across a bunch of sounds at once and override them when I needed to was really, really helpful. Let me switch back here. So one of the things I would like to really focus on in the future, and I think is a really important aspect of this, is spatializing reverbs. Wwise has a new plugin, Reflect, that I have not. I was hoping to actually have a demo showing that in real time today, but I didn't. And I actually think it's something to note, and maybe actually of relevance to my talk as well. This project came out earlier this year, and it uses a version of both Unreal and Wwise that are much older than what's available now. And that's kind of the exciting thing about these spatial audio tools for me. There's so much effort being put to these tools, so much constant updates and support across middleware, across engines. So this is a project that came out this year. Unreal is now on 4.18, and we had to start on 4.14. There's a new mixer, there's new spatial audio support, Steam came out with some support, Reflect is now available. So it's important to note that these things change all the time, and it's easy to get a little bit of FOMO, but projects have to be done, projects have to finish, we gotta move on, and we have to make the best decisions that we can with what we are able to do. So moving forward, early reflections, spatializing them, getting that material-specific information so those reflections can be emulated to absorb or reflect in different ways based on those materials and the size of the room. That's an important aspect to consider. For this project, like I said, we were using Unreal Engine 4.14. We needed to use Wwise to do some platform-specific compiling for the renderer. The Oculus spatializer that we went with was an updated version of the one that was included inside of Unreal at the time. And we used Wwise to manage, like I said, the platform-specific information And being able to integrate the Oculus Spatializer plugin for PC and the Sony 3D plugin and let Wwise just handle that was amazing. Not only did I not have the programmer resources to manage some CPU needs, I didn't have the resources available to manage integration needs. So I really leaned on Wwise to manage that for me. It was something as a non-programmer I was able to integrate on my own. And through the middle of this project, the Wwise released the Unreal like one-button click integration, essentially, if you correct me. Yeah, so I did the first pass, I just following instructions was able to update headers manually, and it worked amazingly. And I didn't, by work, I mean I didn't completely break the game. And when the one-button integration came out for Unreal, it was easy to move to the next version that we needed. Real quick overview through some of the settings. At the time, this is what Oculus Audio, it was just a simple plugin, and running and being able to enable that, any sound cue inside of Oculus was able to run through this version of the Spatializer. But like I said, we used Wwise, and these are the settings where your Audiokinetic rep will connect you with the plugin support. And again, we had PlayStation and Windows, and that was updated in the launcher. Talk a little bit about the linking and unlinking platforms. If you're not familiar with that, it's definitely important when you need to not only set different creative settings per platform, but also technical plugins, and use that to here. So you'll see this is the PS4. I showed you this already in Wwise. This is the Windows. And once it was integrated, it showed up in Oculus in the settings, and you're able to define the number of reverb volumes. But this is also where you set your installation path for your authoring tools and where your project lives. So Unreal can find it. In the level editor itself in Unreal, there's a visual indicator of what objects have a AK object on them. And you'll see here that the AK object is positioned on the head of this robot, which is where the video display pops up from. That's another aspect to really consider when spatializing, is where you attach objects. Because we have this increased sense of proximity to objects now, and we want to be able to, I really recommend separating the detail out and spatializing them in a way that's appropriate. So a lot of times the location will default to the ground. So if you have a character and you have Foley sounds, sometimes it just defaults to the ground. So the Foley sounds need to be moved up to where the object is, to consider moving the voice to the throat area. Even a couple of degrees of difference with spatialization can be noticeable, so pay attention to that. And in Unreal, the Wwise banks are shown here and they're brought in as U assets, and you're able to set them whether they're load globally. You can use blueprints to set them dynamically, which is what I did. I labeled these by area, so I knew when I was going into an area a little bit ahead of time. So I would preload the sound bank for that area to manage my memory usage. And the events were, I get called through an event picker here, and those reads your Wwise project. This is an example. So I want to show, so like I said, when we moved into an area, we knew what location we were in. So I wanted to load a sound bank appropriately for that. But I also wanted to set a switch so that reverb layer that I showed you before, the correct one would play. So this is a blueprint in Unreal that did two things. It managed what may or may not still be an issue with Unreal and Wwise. At the time, we weren't able to get a callback to Wwise from Unreal to know when a sound had stopped playing. And in this particular game, they needed that information to allow visual events to be triggered. We were using sound to drive animations and gameplay. So we had to manually enter the length of the reverb asset because I wanted to give it some time. So that's one way that you connect with Wwise, and that here we have the blueprint setting a switch, how it connects in. That switch then in the sync connects to the layer, sets the switch state, and plays the correct sound, which I already showed you. So there's a few considerations, but I think we're out of time. Are we out of time? Like I said, consider about where you're attaching these sounds to. Details in VR is very important, and distinction in detail is important as well. But like I said, because we have the proximity is a little bit is different. Our perspective and our understanding of that proximity. Also, consider the difference between positional and spatializing sounds. Not every sound necessarily needs to be spatialized. Something that comes up again and again in the VR track. Not only does it save resources, it also not everything needs that kind of detail, and giving some vague positioning can actually help define other things in the sense that, the same sense that mixing can be a reductive process, right? So when you're getting this muddiness and you're not getting clarity in your mix, consider not only removing spatialization to get a diffuse position, but also moving a sound, if it is spatialized, giving it some height. So we get a little more distinction and clarity between the space of that, the spatial mix. So another thing that Scott Selfin just brought up in the spatial sound for Windows talk just now, consider the cone of confusion if you're not familiar with that. It's a phenomenon that we have a hard time discerning whether a sound is behind us or in front of us at a certain point. By moving things in maybe slightly non-obvious ways, we can kind of override that a little bit and help clear up things. So, thank you.